Today, I have some insights on millimeter wave imaging at Rohde and Schwarz. I would like to start with a brief introduction into millimeter wave imaging. Where do we come from and where are we aiming at? What are the benefits and alternatives? Then looking into potential applications, and then in the end coming to a couple of practical examples. Where are we actually coming from with millimeter wave imaging? So it all started around 2015 when we released the first body scanner, the QPS. That's also probably where you know Rohde and Schwarz from. So when you go to the airport, you go to the security scanners, you get screened, and it's detecting forbidden objects like knives or weapons. We then had a customer requesting us to perform these kind of measurements on an automotive bumper. The reason for that is because the QPS is working at the exact same frequency as the automotive radar. So we made an image of the bumper, we realized where the problem is coming from, and we had a potential solution for the customer. The big panel was a little bit too expensive for the customer, so what we did is we reduced the size of the panels, so to say cut it by half, and this is how the QAR was born. The instrument was used in R&D, just to develop bumpers, to develop radomes. And when it came to production, we had to realize that this image is very useful, but the product is too expensive. So we had to reduce the costs, and we did so by reducing the amount of clusters. And that's also one of the benefits of the QAR 50 or of the QAR 50 and the QPS is because it's super modular. So we can use 2 clusters, we can use 4 clusters, we can use any combination depending on how big the object is that we want to make an image of. And that is how the imager is born. So the imager that I have here on the table is the one cluster solution. So that means it's consisting of one single cluster. If we have a look on the device, so you can't see it here because it's hidden behind the monitor, that's why I have it here on the slide. If we look underneath, we see our millimeter wave imaging cluster. And that's basically the core of the device. And that's also the modular piece. So we can use 1 cluster, we can use 2 clusters, we can use 4 clusters, or even more, depending on the size of the object. So how does that cluster work in general? Each of these clusters has 96 transmit and 96 receive antennas. So what we do is we transmit a signal, wait for the signal to get to the object that we want to make the image of, get reflected, and then we measure the time and the intensity of the signal when it's coming back. So what we get from this is a 3-dimensional volume. That 3-dimensional volume has a lot of information, is very bulky in size, and is difficult to interpret by machines and by humans, because we are all used to 2-dimensional images. So what we do to make these images easier to interpret is we can either look at each of the individual slides by stepping through them, or we can look at the so-called maximum image projection, or short, the MIP. So for this MIP is what we do in this configuration. We look top to bottom. We step through all the slices and look where is the voxel with the highest reflectivity for each of the Z vectors. That's how we create this 2-dimensional image. There's another technique called ISAR imaging. So ISAR imaging is coming from SAR imaging, and SAR means synthetic aperture radar. This technique is known for years from satellite imaging. So the radar satellites are moving around the Earth, and they are capturing constantly images. These images are then combined. With ISAR, that means inverse synthetic aperture radar. So what we do is we don't move the satellite, but we move the Earth. In our case, the Earth is not as big as the Earth because we are using smaller DOTs, so they are easy to handle, and we move them under the scanner. This is how we stack all the images together, and then we create one image with higher resolution. So you can see it on the slide here, where we have all the single images. So one image, another image, image number 3, image number 4, and here we have the ISAR image. So the ISAR image is a combination of all the images that you see above, and you can see how tremendously the image quality is increased by ISAR imaging. What can we actually do with these images? What are potential applications? Where do we see this instrument to be helpful for our customers. The first category is pharmaceutical products. So what we can do with pharmaceutical products is we can perform a completeness check. So we can check whether all components of this pharmaceutical product are contained within the package. We can also check the integrity of the package so that all the components are there and the components are intact. We can also check for the traceability. So we can create a digital twin and then we can follow that digital twin through the delivery chain. The second application is logistics and e-commerce. There, we can also check for the completeness, so that means that the item that the customers ordered and that should be shipped is actually in the package. We can also detect leakage and humidity in the packages. So if an article is broken, it's spilling the liquid in the package, we can detect, okay, something is wrong with that package. Here also, we can check the traceability, and it's kind of asset protection because you can ensure that the stuff that should be going to your customer is actually going to your customer and not your employees are taking that stuff away. The third application area is in the food and beverage industry. So there, of course, we can also detect leakage and humidity if the package is broken. We can check for contamination, and we can also check for proper sealing. So that means that the product is safely closed and the best before date can actually be kept. These are the potential applications. What are the alternatives and the advantages and disadvantages of each of these possibilities? Let us start with millimeter wave imaging. So millimeter wave imaging is easy to handle. And with easy to handle, I mean there's no safety precautions required when using millimeter wave imaging. I can stand right next to the device when I perform the measurements. You can step right into the body scanner when the security screening is performed. It's non-ionizing radiation. It's safe for humans, safe for other organic structures. So there's absolutely no alterations when you walk through that scanner or when I stand here next to the scanner. We have the see-through capabilities. So in contrast to the camera, we can look into the packaging material. We don't only see the first surface, we can see inside the package. It has a slightly higher price than a camera, but it has these advantages. A second alternative would be using a scale. So scales are on the market for quite a while already. They are relatively cheap, but unfortunately they have no imaging capabilities. That means they just display the weight of whatever is in the package, but they don't show what exactly is in the package. So they can't really distinguish between there's a high-end smartphone in the package or there's just a couple of stones in the package by chance having the same weight as the smartphone. With the camera, we have a very high resolution and we have a very high speed. Unfortunately, we have no see-through capabilities. So once the product is packed, there's absolutely no chance that we can have a look that the correct product is in the package. Last but not least, the alternative would be X-ray. So X-ray is using ionizing radiation, so that means we have to be cautious because it's not safe for humans. There's always a little bit trade-off, and depending on the application that you want to cover, there's different alternative solutions that you can use for the checking. Let's have a look at some examples, and before we look at these examples, let's go through an exemplary image where I show you the difference between the maximum image projection and looking at the image slice by slice. So here we have the image, the volumetric image of a box of eggs. So on the left, you see the photograph. The first image is the first layer. So I call this 0 millimeters because that's the surface of the package. It's uninteresting because that's what we see with the camera. So let's go deeper. And deeper means we look at the images on the left, or we go from left to right. So when we go 1 centimeter inside the package, we can already see the top of the eggs. So here we could count the eggs, we could check for the integrity of the eggs, that the eggs aren't broken, and we can also check whether all the eggs are in the box. If we go deeper, we start to lose signal strength, but we can still see the packaging material here, for example. So what the image here shows is the different things that we can detect with this box of X. So I mentioned completeness. You can see this on the middle picture where the top left egg is missing. And in terms of integrity, you can see that on the right image where the top right egg is broken. With having this in mind, let's have a look at more practical examples that I have prepared for this presentation today. For this example, I have a small tool that's using machine learning. So we have a web interface here, and this morning I have trained a couple of samples. So for each of the challenges I have here, I just trained 20 examples. So 20 good ones and 20 bad ones. So where something is missing, something is broken. 20 is a very low number for an AI. So if you increase that number, of course, you can also scale this to more complex problems. The first problem I brought is from the pharmaceutical industry. So I have these boxes here with blisters and leaflets inside. Unfortunately, one of these boxes does not contain a leaflet, and the question is which. So with our solution, I can just find it out by not opening the boxes, but just scanning these boxes. So I put the first box here, let it scan, and you can see that was obviously not the box which is missing the leaflet. Now, let's proceed with the next one. Let's see if this box is missing the leaflet. Okay, so it's already the second box that is missing the leaflet. My job is done. I know where to put back the leaflet. The second example I brought is from the logistics industry. Again, it's a very simplified scenario, and the only thing I want to know is whether the smartphone is in the package or not. Again, this is only trained with 20 samples. So if you have more challenging scenarios, the only thing that changes is that the training takes a little bit longer. In order to activate that scenario, I have to connect to my device and load the respective scenario. I then have to enter the auto trigger mode such that the light barriers trigger the measurement. So for the first measurement, we will hopefully see that my smartphone is in a package. So you can see the image of the smartphone here. It's well detected by the algorithm. Now I remove the smartphone from the package, and optically for a camera, there's no difference. So it's the same package, but if I put it here, you can clearly see in the image and also by the AI that the smartphone is no longer present in the package. The last example I brought is from the food and beverage industry. So I bought two glasses. One is already empty, which means the vacuum seal is broken. You can hear this because it's a pop on open, first open glass. So this one is the open one, and I have the closed glass where the vacuum seal is still intact. So what we can do with the device is we have a complex volume. That means we can see the face of the reflection on the lid of the container. So we can see whether the seal is already opened or still closed. Let's have a look at what these images look like. This is the closed glass, and it's correctly detected that the glass is closed. When I put the already opened glass in here, you can again see the difference already in the image, and it's also detected as an anomaly by the device. The three examples I brought are very easy and can very quickly be trained on our machine. In case you have any specific requirements or applications that you want to test, don't hesitate contacting us. You can do so by scrolling down on the web page and clicking on the Contact Us button. Thanks for watching and looking forward to seeing you and your application.